team, we are ready for section 2.4, solving linear inequalities. There is one reminder I want to give you guys. Don't forget, when we multiply or divide an inequality, those are the less than, greater than, less than equals to, greater than or equals to, by a negative number, we must switch the inequality. Okay, so we'll do a couple examples just to kind of refresh your memory. So when we're doing the examples of solving linear inequalities, we're going to do it three ways. One, algebraically. One, we're going to use the intersection, and we can do that on our calculator. I'll show you how. And also use the x-intercept method, which we've done before when we were using the zeros to solve for a linear equation. So let's take a look at example 1 first. We have 3x plus 1 greater than or equal to 4x plus 3. It does not matter which x term we move. Let's go ahead and move and subtract the negative 4 from both sides so we can deal with that dividing by a negative. We get negative x plus 1 greater than or equal to 3. Subtract 1 from both sides. We get negative x is greater than or equal to 2. Now we have to divide by that coefficient of negative 1. But when we do, we have to switch the inequality. So we get x is less than or equal to negative 2. Now, this answer here is the inequality. If you're asked to write it in interval notation, it includes negative 2 and everybody to the left. X is smaller than negative 2. So remember, interval notation is always left to right. So it'd be parentheses, negative infinity, all the way to negative 2 with negative 2 included. Sometimes they're going to ask you to graph the solution. So we know that negative 2 works. In the past, we would have put in a colored circle, closed circle at negative 2, and we would shade everybody to the left because x is smaller than that negative 2. If we're using the interval notation, we're going to use the same bracket or parenthesis depending on whether it's included. Ours is included, so we use the bracket negative 2 and still shade to the left. Now, for some of us, if you're still struggling with interval notation, graph it on the number line first and look at the endpoints. It ends here at negative 2, starts way over here at negative infinity. Negative infinity is never included. So we always use parentheses and then everybody in between. So you have your endpoints always left to right. So if that helps you, graph it first, then write your interval notation. So in problem 2, we're going to want to solve this inequality using what's called an intersection method. So we're going to use our graphing calculator, and I put a couple of screenshots here. On the first shot of our graphing calculator, we're going to put in the first equation that's on the left, the 2 times the x minus 4 divided by 3. Now notice, I'm going to put a couple of extra parentheses in there just to make sure. Order of operations, it would still work, but some people have a lot of careless errors with the parentheses when they're dealing with fractions. So to me, it's always helpful, just everything in the top goes in one big parenthesis, and if you have more stuff in the bottom, everything in the bottom goes in parentheses. And then the right-hand side is our y2. Again, both the 3 and the x are in the numerator, so use those parentheses divided by 5, and then minus 8. If you're worried they're going to stick that 8 with a 5, they're not. Calculator uses order of operations, but it also wouldn't hurt you if you wanted to put an extra pair of parentheses around just those fraction pieces. Let's actually go to our graphing calculator. So if you try to graph those two using just the standard window, notice we don't see where they cross. So you may have to do a little bit of detective work sometimes to see, does it look like they may cross to the right or cross to the left? So if you kind of squint, you could tell that the right-hand side is larger than the left-hand side. So odds are this left-hand side here is going to be where it meets. So we can change our window. Let's say, let's go to like maybe negative 100 for the x, and we can go to, I don't know, negative 50 for the x. We can do a scale of 2 perhaps. And then we don't know about the y's either. So we can do a negative 100 for the y's, negative 50 for the y's. And we're just kind of casting a large net over there in quadrant 3. And we graph and we go, okay, so that looks like we have an intersection somewhere around there. If you want to, you can at this point go down to zoom fit, and it will take that window and just kind of make those important pieces a little bit clearer. It'll kind of center them for you. Works most of the time, sometimes it doesn't, but it's still not too clear, but we can still work with it. Now, remember, we're looking for where it intersects. So let's use second function, calculate. Let's go down to intersect. And the first curve, notice up here at the top, it will say the Y1. So that was the left side. So we can move that cursor closer to where I think they intersect, hit enter. Notice it switched over to the second curve, which is in red on mine anyway, and that was the right-hand side. And then we hit enter. And then, yes, we want it to guess, same as when we were finding the zeros before. And it gives us an intersection of negative 80 with a y of negative 56. So again, we have this intersection point here where x is at negative 80. But if you recall, the question wasn't where do they intersect? It wasn't an equal sign. It was asking us when 2 times x minus 4 over 3 is less than or equal to 3x over 5 minus 8. This left-hand side we said was y1, and the right-hand side was y2. We need to determine when that first equation in this picture is graphed in blue, and the second equation that we put in, which is graphed in red, that's the left side and right side, when is the left side lower or less than? So as we see here in the screen capture of D, that if we scroll down on the blue line there, it is below the red line. It could be a little hard to see. We can zoom in there a little bit, but Y1 is lower than Y2 everywhere from the intersection point here where X is negative 80, all the way out to negative infinity, because these two lines here go on and on forever. So our solution set is from negative infinity to negative 80, with negative 80 being included. Now, example 3 kind of has the same idea, but now we're using the x-intercept. Remember, the x-intercept means that the y is 0. So we need to get everything over to the left-hand side or right-hand side and let that function have an inequality set to 0. I would get rid of the fractions first. Let's multiply both sides by the LCD of 15. So when we multiply both sides by 15 on the left, the 3 divides into the 15 5 times. 5 times 2 leaves us with a 10 times x minus 4 on the left-hand side, less than or equal to. When we distribute the 15 to the fraction, 5 goes into 15 3 times. So we get 3x times 3 minus 120. We get 10x minus 40 less than or equal to 9x minus 120. Subtract 9x from both sides, we get x minus 40 less than or equal to negative 120. Add the 120 to both sides, and we end up with x plus 80 less than or equal to 0. So when we are working this using the x-intercept, again, this is like saying the function value of 0. So we want to find our 0 or x-intercept. So we can put in the equation x plus 80 and look for where it equals 0. So in our calculator, let's go ahead and plug in the equation x plus 80. And again, we would want to graph that, but notice it does not show up anywhere in our graph, right? So again, we can go to zoom fit, see if that helps us any. Zoom fit, hey, look, so at least it shows up. But you have to be smarter than your calculator. We know we're looking for the 0. We need to be sure that we continue down and find out where in fact it crosses the x-axis. So let's check out our window to see where it actually is. We're only at negative 10 to 10. for our X's, but our Y's are 70 to 80. Let's scooch a lot more left, because notice if our Y's are 70 and 90, we want our Y to be 0. 0. So we need this to be way further left than what it is. So let's try negative 100 to, let's say, negative 70. And we want a Y minimum of, we can do negative 10 to 10. Because again, we want it just to cover 0 for the Y. And now if we graph it, again, we've moved far left, we can actually see the 0. So let's try and calculate the 0. We're going to do the second function, calculate. Instead of intersect, we're going to now do 0. And we've done this before. Left bound, enter. Right bound of that 0, enter. We want it to guess somewhere in that interval. And hey, look, we got our 0 at negative 80. So again, here's some windows just to kind of help you remember how we did. And I think the biggest issue that most students have is determining what the right window is, which means you have to know what you're looking for. If you're looking for an intersect, you have to kind of go, okay, it's going down this way, so I'm going to keep moving it. Just to save time, I kind of knew where everything was, so I was finding those windows in that direction, but it might take you a few times. Oh, I still don't have it. Let me move my X smaller or my Y larger, whatever helps to coordinate that window. So don't get frustrated. I don't want you to think that you should be able to, bam, automatically I know what my window should be. This one wasn't too bad over here because it is X plus 8 equals 0. So you kind of solve it in your head and go, okay, X has to be negative 80. Hence, the X's between negative 90 and negative 70, or negative 100, negative 70, whatever I chose before, should catch that X-intercept. We know our Y had to be 0, so any relatively small interval that captures 0, like negative 10 to 10, should also work. So now we are working with what's called compound inequalities. This is when two inequalities are joined by the word and, or the word or, and, or. So when we're using the word and, it's called a conjunction. So an example of a conjunction with the word and would be number 4, negative 3 less than 2x plus 5, and 2x plus 5 is less than or equal to 7. Because two of those are identical, the 2x plus 5 and the 2x plus 5, we can write this as one inequality. Negative 3 less than 2x plus 5 less than or equal to 7. This only works if you're going from smallest to largest and you have the word and in it. So if you're solving a conjunction like this, we still want to solve for X in the middle. So we would get root of that plus 5 by subtracting 5 from the middle, subtracting 5 from the right, but also subtracting 5 from the left. There are now 3 sides to that inequality, compound inequality. That gives us a negative 8 less than 2x less than or equal to 2, and then divide everything by 2. We get negative 4 less than x less than or equal to 1. Notice that we're still dividing by a positive number, so the inequalities did not change. The top number didn't matter, the negative 8 was already there, but we are physically dividing by a positive number. If we were to write this in interval notation, it would be parenthesis negative 4, because we have a strictly less than, so negative 4 is not included, all the way to a positive 1, but since we have the less than or equals to, we would use the bracket. Note, the solution when you have a conjunction, when you have an and, is either one interval, which is what we got, between negative 4 and 1, or no solution. In other words, if you were to work these separately, and if you were to graph, let's say from here to here, and then you ended up with one from here to here. If there's no overlap, then no solution, okay? When you have the word and, it has to satisfy both at the same time. That's why we only have one interval or no solution. When we use the word or, it's a disjunction, and there is no other way to write a disjunction. So in example 5, we have 2x minus 5 is less than or equal to -7, or 2x minus 5 is greater than 1. So we have to solve both of these separately. So for the first equation, we can add 5 to both sides. That would give us 2x less than or equal to -2. Then divide both sides by the coefficient of 2, and we get x is less than or equal to -1. Writing that in interval notation, we get -infinity to -1 with a bracket with a -1. Now let's work with the second equation. With the second equation, we would need to add 5 to both sides. This would give us 2x greater than 6. Divide by the coefficient of 2, we get x is greater than 3. That means anything higher than 3 would work, just 3 is not included. So when we write the solution here, we still want to write them from smallest to largest, with our first interval from -infinity to -1 bracket, union parentheses 3, comma, infinity parentheses. So notice the solution for disjunctions or the word or will either be 2 intervals combined with a union, which is what we got, or all real numbers. In other words, if those 2 intervals overlap, think of it as graphing it on a number line. If you have one that graphs there to the left, and then the other one graphs here to the right, well, remember it's or. Either, in this example, either the purple or the green would work. So if either of them work, that includes everybody. So when they overlap, it's all real numbers. So in example 6, we're going to focus on the difference between solving an equation or a system of equations versus solving an inequality. So let's say we want to solve for f of x equals g of x, and we have this graph to the right. F of x is a linear equation increasing, g of x is decreasing. And notice we have the point 3, -2 as where they intersect. Well, if you want to know where they equal each other, they're going to equal each other where they intersect. In other words, that point is a solution to both. So it would just be 3, -2. This is a point. I know it looks like it could also be an interval. So context is important. Equality, an equal sign, you're looking for just that point. Now, for part B, it's asking us to solve for where f of x is larger than g of x. In other words, higher or on top of. So here, to the left of that intersection point, the g of x is higher and the f of x is below. So that's not a true statement to the left of that intersection point. But to the right of the intersection point, the f of x graph is higher than the g of x. So it's above it everywhere to the right of that intersection point. So to solve for that inequality, we know they meet at x equals 3, and f of x is going to be higher all the way out to infinity to the right. So notice this is an interval using x coordinates. So I want to be sure that you understand the difference between solving for an equation, you get just a single point, x, y, versus solving an inequality where you're going to put in an interval just using the x coordinates. Our last example is modeling a profit with inequalities. So a company produces SIM cards for cameras. The annual fixed cost, that's going to be important, annual fixed cost for the card is $66,412, and the variable cost is $6 per card. Okay, so all that has to do with the cost to the company. If the SIM card sells for $27 each, okay, So that's a price. They want to write an inequality that gives the number of SIM cards that must be produced and sold to make a profit. All right. So they're asking us about a profit. They did not give us a profit function, which means we have to come up with one. So let's go back in our little Rolodex or our notes if you need to remember how to find a profit. Well, we know that profit is revenue minus the cost to a company. And the first sentence actually gave us information about how much it's costing the company. They gave us a fixed cost and a variable cost, which is our hint that we've got a linear cost function. So we can write the cost function as C of X equals, it's $6 for every car made. So we can write 6X, but it also costs a fixed cost or flat rate of $66,412 per year. And again, X is the number of cards made. But now we have to come up with a revenue function in order to subtract the two and determine the profit. Revenue, remember, is how much money is coming in, so we need to know the price. Well, the revenue function for the number of cards made, and we should say and sold, would be the price of $27 times X. Now, it says to write an inequality. We could just write a profit function and say we want that profit function to be greater than 0. We can do that. Or we can say, based on the revenue and the cost, which must be higher in order for them to make a profit. The revenue, the money coming in, must be higher than the cost in order for them to make a profit. Notice I didn't even put the or equals to sign. We don't want them to equal because then there's no profit. You've broken even. So I would write 27X is greater than 6X plus 66,412. And notice they only asked for the inequality. They didn't ask us to solve it. I mean, they might, there could be like a part B later, but I didn't give you a part B. So you're using your previous knowledge, guys. Don't just do that old homework and go, okay, check mark, done. Keep your old homework. Be sure that you review it because we're going to keep using some of these terminologies and some of the functions that we're learning, some of the equations and formulas. It all just kind of builds on each other. So that's it. That is it for me for this section. You guys are doing so great. Proud of you. If you have any questions, come and see me or your instructor. That's what we're here for. Talk to you soon. Bye.